Hey man, what are you up to? I'm glad you asked. I'm working on setting up Ubuntu and Perforce on my laptop. And Perforce is software for handling larger files. And that's good, especially if you're making a game. A video game. And I may or may not have someone joining me in this endeavor.
Come on, pick up the food!
Anyway, let's get Devlog 2 on the road.
Alright, I'm gonna start off by saying I've not had the most productive month. I've worked on implementing the spells and their functionality, setting up Perforce, and designing the first boss fight. Although it may not have been the best way of doing things, I started with a server version of the implementations and then later went on to fix the replication. Actually, that might mean we need to cover something else first. If you're wondering what replication means, well, it's probably about time I explain it. Menhir is a multiplayer game after all. Unreal comes with built-in networking. It's based on a server-client architecture, as opposed to peer-to-peer. The server is considered an authority, and clients are considered, well, clients. The name authority for the server is not a term chosen lightly either. It means anything that is on the server is considered correct, or true rather. For the sake of interest, and for the sake of learning, let's dive deeper into Unreal's networking. If you're not interested, you can skip ahead to the timestamp in the description. Objects and actors exist on the server, but a clone of them also exists on the clients. If a client moves an object locally, and locally meaning only on the client itself, it will not be reflected on the server, and therefore not reflected on other clients either. What we do with networking is essentially synchronizing these actors across every client and server. When something changes on the server, it also updates the client's version of the object, if we've chosen to replicate. You would consider this action multicasted, meaning we tell all clients and the server itself that an update was made. If we only wanted to notify one client, that could be done from the server as well. The most important thing to remember is that any code on the server will always run without question. But what if a client wants to tell the server to, for instance, spawn an arrow?
Please Lord, can I fire an arrow?
No.
The server is unaware of the client wanting to fire an arrow. That is done only on the client itself. This leads us to discuss the three types of RPCs: server, client, and multicast. And just for the record, RPC means remote procedure call. The server RPC is executed from a client. Essentially, what we're doing is telling the server, hey, could you please execute this function for me, so it's official, winky face. Here there's an issue with security, which we will get into later. But for the firing an arrow here, we'd left click on our client, and once left click is pressed, we will tell the server, spawn the arrow at this location, pointing in this direction, as soon as possible. The server will then validate the call and do that for us. Since the arrow is now on the server, all clients are aware of it, and the arrow is now replicated. But what about the case where we'd want to tell the client to execute something on behalf of the server? Say that we want a power-up to only spawn for a client, but it's based on an action that happened on the server. In comes the client RPC, called from the server, directed towards a specific client. The server will ask the client to execute certain code so it knows only the specific client is affected. If we were to spawn a power-up because a boss died on the server, but only for the mage, then we'd find the client that is the mage and tell it to spawn it for him. This means no other clients can see it. Lastly, let's take an example about animation. What if we wanted one and we wanted to make sure that it's played for the server and for all clients? Here's where we'd have to use a multicasted function. This essentially says, hey, I want to execute the code here and also on all clients connected to me. Multicast RPCs can only be called on the server for that very reason. You can't broadcast sideways. That would be considered peer-to-peer essentially. Now there's of course some security aspects here.
I hate
Skill.
I hate
Honesty.
and I hate
Fun.
they drive me to
Cheat.
Cheats only happen because we allow execution on clients. Clients can tamper all they want with their registries and the game code that's loaded into memory, meaning they essentially have full control of the program. The simplest way Unreal allows us to detect cheating is by using the server RPCs. When you implement a server RPC, you're forced to implement a validation function along with it. The validation function can be used to detect if something's amiss. Say that someone locally changes their health to 2000, but their health on the server should be 95. Once they send the 2000 to the server, we will check if it's feasible for them to have that health. If not, then we will detect them as having cheated. This is how we detect cheating. We check if any variables or actions are unrealistic for the player as it is currently. I hope that may have cleared up some networking details in Unreal. There's of course a lot more to go over, but this is kind of just the basics. But let's talk actual dev work now. As the opening mentioned, I have now set up Perforce, so these large files can go to this bad boy. There's a limit on GitHub of 2 GB, and assets for games, well, they grow quite a lot in size, and very quickly. And since I now have an artist on board, the assets he will produce will be a lot larger than my CPP files. Check him out, by the way, I linked his Instagram in the description. So I slammed Ubuntu on my old gaming laptop. And then I got an indie game studio license for Perforce. Just as a side note, if you're a studio of 5 or less, you can get a license for Perforce for free. You just have to cover the hosting costs yourself. It was also surprisingly easy to set up, even though I just used the CLI. And now I've source controlled directly in Unreal. It is a bit strange to work with though. Perforce isn't Git. So I'll have to go over the differences when I actually understand them. Next video. Now that I've actually found a way to work with someone else, I could start some game development. And so I spent time implementing what I could of all the spells, tie in the animations, the anim notifies, and so on, and that allows us to go into the details on the spells. Magic in Menhir works in the way that you have 3 elements to choose from and 2 slots to put them into, leaving us with 9 permutations. From the last video, you will note that we made 9 animations. It's important to me that players are in full control of their actions, which have caused me to make some unnecessarily difficult state machines. There are 3 different elements.
Water. Fire. Air.
Each mage weapon has a list of spells that they can cast. When we've chosen 2 elements and you right click, that's when the spell is conjured up. Once the spell is spawned, we wait for the animation to reach a ready to fire state. If the spell is ready to fire, then left clicking will fire the spell. And the state machine is then for handling, what if someone lets go of right click before firing the spell? What if you have channeled a spell and you want to stop it early? What if you let go of right click while firing a spell? Then came implementing the spell's functionality. I've designed it so there's a base spell, and from that we inherit all of our actual fully implemented spells. Or we implement them. They're inheriting from the base spell. So since all the spells can vary quite a lot in how they function, I decided to generalize as many aspects of it as I could. So we always call the same functions, but it's polymorphic, so the inherited spell determines what to do. Say for example with the fireball, it's a projectile. So I spawn a projectile of BP_fireball in my spell socket. Once I fire, I instruct the BP fireball to let go and inherit the current rotation of me and then add velocity in the direction, which is my forward vector, or the camera's forward vector to be completely specific. I then have a collision on the fireball, and when it collides, it explodes, and the explosion is a separate blueprint. I could go into more detail on how the other spells work, but you get the gist of it, so let's move on to the next chapter. I also spent some time migrating from 4.22 to 4.25. The biggest hurdle was that there's a new way to select roles, and this is for networking. Now there's a local role and a remote role that you can get. The reason I migrated was to be able to try and use a new Niagara Niagara, am I pronouncing that right? Niagara particle editor, that rather than their old Cascade particle editor. Since I'm by no means a VFX expert, Jesus, and really wanted to make some particles of my own, and the Niagara editor, and the Niagara, I'm by no means, and this is not going very well. I'm by no means a VFX expert, and I really wanted to make some particles of my own, and the Niagara editor is a lot easier to work with than Cascade. As you may have noticed, there are particles here and there now. Some of the spells have them, some of them don't. The main intention was just to add particles in the left hand of the spellcaster to indicate which elements are currently loaded. As you can guess, the orange-red is fire, air is white, and water is blue. Well, thanks for watching through another devlog, and next devlog will be focused more on implementing graphics and more AI, so that I can test the melee and spells. The roadblock for me now is that, yeah, I can implement spells, or I can implement melee, which I've already done, but the problem is I don't have any dummy to fight, so I can't really test the flow of combat, and it's hard for me to enter or test if I can get into a bugged state. So I'm going to make a boss fight. I'm going to make the first boss fight. And I've already designed how he's going to function. I just need to implement the functions for him to actually execute. So, you know, throw projectiles everywhere or poop on the floor and scream your head off. I don't know. But anyway, we'll go through that in the next devlog. Thanks for watching. If you're interested in following my progress, then hit the subscribe button. Maybe follow me on Twitter. I don't usually do much there, but if I had more followers, I probably would. Alright. Good luck with your own projects.